Okay, good afternoon and welcome to the next presentation with 7th Annual ICS Cybersecurity Europe. The next presentation is from Philip Tonkin, Head of Cyber Operational Technology at National Grid. Today, Philip is going to be talking to us about agile OT security for evolving networks. Philip has worked in the energy business for over 20 years. He's working in a wide range of disciplines, from field engineering to senior leadership positions. He's always been passionate about solving the challenges of digitization in the energy supply industry. Using his understanding of systems used by the industry, along with experience in making decisions as an asset manager, he's led a number of key projects to move forward the understanding of cyber threats. Now, as an OT leader with National Grid's security team, his focus is in securing operational technology that underpins the operation of National Grid's transatlantic business, from gas transmission to electricity generation. So without further ado, Mr. Tonkin, we will hand this session over to you, and thank you for joining us.
Good afternoon, all. So this afternoon, really what I want to talk to you about is how we go about solving one of the greatest challenges that we have within our space. We have, a vast amount of variety in the technologies that we have to support and secure, and it's a technology set which is continuously changing because the environment in which we're operating is further digitizing continuously. It's a space in which we have to keep pace with the constant evolution of technology, whilst providing the best value we can to our customers and the needs of society. So as we consider how we maintain pace with technology, we've got to find a way of maintaining pace with security, in particular in an environment where we still have a number of legacy challenges to solve. So the energy industry itself is continuously evolving. Digitization is something that it may be seen as emerging now, but really has been happening for almost 20 years. The turning of electromechanical devices into microprocessor-based controllers that which started to take analog logic and turn it into computerized decision making. But as the technology matures, as we accept that and it becomes more and more commonplace, we've have a legacy of issues where systems have been digitized without having any consideration on security, through to the latest products that are still operating in a very similar way, but have now accepted the need for technology and embedding those security capabilities adds another layer of complexity and a change in how we architect our sites. And it was great to hear this morning, Andre's talking about some of the secure architectures that are required within substations and some of the capabilities that utilities in other countries are implementing, really starting to adopt those the things, the security controls that are typically in the IT world, really starting to see them being embedded and accepted within the operational technology environment. And in the energy industry, we've always had assets on very different scales, from large rotational planned thermal power stations through large transmission sites, transmission networks, large gas compressors moving energy around countries, getting it out to the demand centers, where it then reduces in scale. There's a huge shift now in moving those sites which were always reliant on technology, moving the capabilities further and further down into the network. So with the concept of decentralization, we're talking about the challenges of moving away from large power stations, which are huge multi-billion-pound assets, which are have always been highly digitized and have always had a lot of computerized capabilities and a lot to secure their large substations with with large complex networks and items that need to be secured. We're now moving down into a world of small distribution substations. We are talking about assets attached to wooden poles, assets in people's homes, which all of which form a fundamental part of the the energy network now. And one of the huge challenges in that space is the sheer diversity of different sources of energy. But those sources of energy are incredibly important on our journey towards decarbonisation. No responsible society now will not embrace any opportunity that exists in order to to remove carbon from our our homes and our lives. Therefore, we have to accept that these technologies are a fundamental part of our energy balance, and form a fundamental part of securing society, and therefore making sure that we have in place architectures and capabilities to support those technologies is really important to us. So we're moving, we're moving away from from those large rotational plants through to things like large offshore wind farms, through to large scale solar installations, all the way through to to the sorry, my slides just jumped forward a second there. Right the way down to solar installations on people's homes. But one of the key, big changes is the introduction of things like dynamic demand. The ability for demand to be varied in response to the requirements of the network stability. With these,
Phil, sorry to interrupt you, mate. There's a black box on your slides, and I just was wondering if you could check that. Do you see it on your end?
I don't, but let me just see if is it gone away now?
It's gone. I think there's one at the top too.
I'll look around for some more dialogue boxes that seem to be springing up.
Thank you. As somebody mentioned, there might be another one. I can see something at the top of the screen as well, above the energy industry, over kind of to the right.
I will try and get rid of that without completely stopping the presentation. So
okay,
let me
thanks, mate.
Yeah, if you can see that, I'll just keep going, and then I will try and do that at the next slide. So so we've got. So with the introduction of technologies which are more distributed, these sites are much more numerous. So there are many more small distributed storage facilities, solar facilities than there ever were installations of coal-fired power stations or gas-fired stations. And with those technologies are much cheaper to implement. They're much faster to implement. But the fact that they're delivered at lower cost means that we can't necessarily introduce capabilities that are incredibly expensive to secure those facilities either, because the solutions we implement have to be cost effective for the and appropriate to the scale of the solution. But at the same time, the aggregate risk associated with multiples of these sites with common technologies is as big as the large power stations ever were. So it is important that we think about those coming up with small scale, agile, repeatable solutions that can secure the capabilities that organizations like the large utilities, the transmission network operators or distribution network operators need to have in balancing the outputs of them, but doing it in a way which is cost effective and proportionate to the size of the sites. But another one of the sort of emerging challenges is not all of this technology is small scale. In some cases, the ways in which we're solving the technical challenges of decarbonisation are some very large scale technologies. So the introduction of more and more HVDC interconnectors is a good example of that. These are large electronic devices. It's power electronics. It's working at tens of thousands of volts, and huge currents, often carrying gigawatts of energy, but completely reliant on digital technology. And although we've operated the assets like that in the US and the UK for many years and around the world, the increasing volume and increasing reliance on interconnectivity and large-scale technologies like this introduces a new dynamic to the need to secure digital assets. So we've got, are we still having issues with the dialog boxes? Are they all gone?
I think that's fixed it.
Good.
If anything else comes through, I'll let you know.
Thank you. So one of the things we have to, we need to keep pace on with is the, are there other threats to the energy industry? We have to constantly keep an eye on where the threats are coming from. We hear a lot about the nation state threat actors. These are the largely publicized events that have hit, they hit the Ukraine or hit Iran. We're very familiar with the obvious interest that people have in nation state threat actors, and we can never be complacent to the types of activities that are going on within those, from adversaries that are representing the interests of nation states. However, what we've seen over the last 18 months and to 2 years is a real growth in the targeting of infrastructure companies by criminal organizations, whether they are acting purely in order to, for their own financial gain, or whether those criminal organizations are working on behalf of nation states. That kind of attribution isn't necessarily that important to us, but what we do see from those groups is a different sort of attack. They are very, they will look to use multiple tool sets in different ways, in new ways, as described as hybrid attacks, because they are then, in some ways, they may be looking to use crypto malware in order to, to lock you out of your systems, in order to extort money. In some cases, they may be trying to exfiltrate data. In some cases, they may be looking to deny service. In all the cases, maybe looking just to gain persistence within your network in order to either use or sell on that access to other groups or other adversarial groups that might have a different intent. So in most cases, it's about the monetization of the attack. So although we hear about those nation state attacks, and we also have a great deal of intelligence that tells us that many nation states are unlikely to initiate an attack, it doesn't mean that they're not trying to maintain access to systems of interest, and it certainly isn't going to stop criminals from wanting to try and get money from organizations that will put reliability and availability at as their top priorities. They are the most likely to respond in a way that the adversaries want, which is to ultimately try and gain access back to their systems quickly and without any loss of information. So it's very important that we keep pace and understand what those issues are and may be. So we do have to keep a constant eye on what the nation state adversaries are doing, and we track the intelligence around those, but we have to keep an eye on what's happening in the criminal world just as much, because these are the tactics and techniques that move fastest, and we need to move as quickly with in order to protect our the systems that are critical to society. So how do we do that? How do we keep pace, with adversaries that move a lot faster than us? Because it's not, we don't just have to keep pace with adversaries. We have to keep pace with constantly moving technology. Digitization is moving at a pace that nobody could have imagined a number of years ago. The technology that we all hold in our homes, in our hands, it has enabled a huge amount of additional functionality and capability. That same technology is trickled down into the operational environments. So those environments are constantly changing, and each time that brings a new security challenge. Sometimes that new capability brings new security functionality, and that's great that now we don't think twice about whether a device should or shouldn't have logging in it or role-based access control. Maybe even an element of host-based intrusion detection or protection. These are all things that are very, very beneficial to defenders such as ourselves. However, enabling those technologies requires infrastructure to be in place to support them. And and I said, keeping pace with what the adversaries are doing. Every time they come up with a new tactic, we need to come up with a new defensive tactic, and that requires us to be flexible. And that is a huge challenge in an environment which is usually built to be static. Flexibility is not something that we often build into our operational technology environments. We build in determinism. We want to build a site that has, meets a set of functional requirements. It delivers against the capabilities that we want it to. We commission it and we test it to the extreme to make sure that it'll operate under all possible conditions. And then we commission it and we leave it there for as long as possible to extract value from it. And that's common across nearly all industries using operational technology. So the pace of change is deliberately slow. We often will select N-1 technologies in order to make sure that we've got stability, because reliability and integrity is the most important thing to us, as when we're going to trying to manage a critical process. We are just trying, we have got to maintain very, very high engineering standards. We can't rush something in, just to see how it works or to try something out. In order to maintain a safe and reliable environment, everything we do has to be properly documented, properly tested, properly labeled and drawn, and all of the information captured against those high engineering standards. And delivering change within these environments requires skilled engineers. We will refer to operational technology engineers or ICS engineers, but these are, it could be wiremen, it can be people who are trained to the sufficient safety standards. All of these things are very hard for us to maintain, and they are, finding those skills to deliver against the volume of change we might want to is very, very high. So we need to make sure that when we do have access to those resources, we're doing it in a way which means that we don't have to do it again and again. And the environment itself is complex. We are working in industrial environments. Every single one of those environments has different health and safety requirements. It has different sets of hazards, different sets of accreditations that people need in order to be able to work in those spaces. So if we can, if we can minimize the amount of work that we have to do in those environments, then we can really start to address the challenge. So moving on to some of the issues, from the issues, how do we start to solve those problems? One of the things, and I'm very conscious of, and the title of this is around how we do these things in an agile way. Agile doesn't always mean doing things quickly and dropping in something at the lowest, the minimum viable product. In this context, what I want to describe is how we can build a platform which will allow us to be agile in the future. And that actually allows us, means that we have to start in quite a specific way, which feels very much waterfall rather than agile. The first challenge for a security function, especially for those who are coming from an IT world rather than the OT world, is to actually get a foothold in the environment, is to be accepted into that environment. And quite often that starts by doing some project with a passive technology. We demonstrate with all sorts of other capabilities why that we are maintaining a degree of separation. But we still have to physically put something into those sites, which means we have to engineer something that fits in the environment, is recognized in that environment. But it's quite often those are point solutions, and they don't help us move things forwards into the future. So it's very important that you understand all of the capabilities you may want to have in the future before you set about on a design. Not to deliver just the point solution that may deliver your first detective technology. Understand where you want to go and how you want to do it. Because if you do it that way, you don't have to go into sites multiple times. You can really minimize the amount of physical works that you have to build. you prevent a lot of rework in, a replacement of components you may have already had to replace in order to get to where you're going. And so it's more efficient in that it will help you avoid any regret costs. It will, and once you've landed in that space with a product that works, and you've addressed the concerns of engineering functions, they can see that you're able to operate in a safe way, in a resilient way, and operate within the standards. It's much more acceptable for any work in the future, and it really does help to build partnerships with different parts of business units which may be reluctant or reticent to implementation of technology in their space by another group. So by doing so, one of the ways of doing this is by building a platform that you can start to layer your technologies on. So one of the one approach to this is by start by having something which is universal and repeatable. So identifying a pattern which can be used across multiple different technology areas, whether it's something that has to operate in a small above ground gas installation or solar installation, all the way through to a power station. What are the standards that you want to build this to, to make sure that it is fit for purpose in those different environments? There are many IC standards, for example, out there which will define the types of the ways in which things need to be built, and that often demonstrating you understand those things can really help moving things forwards in starting to construct something that'll work within those spaces. Start with something that's familiar, for what for the environment that you're working in. It's incredibly important to to understand the types of equipment, the vendors and manufacturers that are often used within these spaces, rather than trying to layer in technologies that you may already have support models for. A great example of this is some of the appliances that might maybe you want to implement. You may be based on technology which is very fit for purpose in a data center or a server room, but not in an industrial space. There are many industrial alternatives out there, and finding something that is already familiar, is already recognized, can immediately buy confidence in what you're trying to roll out into that space. And always remembering that being safe and secure is paramount in the solutions that you're delivering. But one of the challenges with that is, in order to demonstrate that you are doing something securely, you have to accept that you're defending against a number of different vectors. And one of the points I'm making there really is that an important vector for for all defenders to be thinking about is insider threat. There are a number of utilities, number of industrial organizations that have identified the need for security, have implemented detection technologies, and the people who are implementing them, tuning them, and have access to them are the same people who can access and program all of the devices, which means that there is absolutely no benefit in the defense that they give against insider threat actors. And it is incredibly difficult to talk to the people you need to work with in implementing these things and then tell them that these technologies are there to watch them as much as they are anybody else. And it's about having a very open conversation and a very respectful conversation about the need for mutual distrust in the most respectful way you possibly can. It is important to make sure that that the people you're working with realize that these technologies can quite often be there to make sure that either they or their colleagues are not doing something that they shouldn't be, whether coerced, deliberately, or accidentally. It's very important that they understand that sometimes this equipment being installed within their sites, they may not have access to, they may not be part of the solution, or at least not on their own. There are some very important times when in order to understand a problem, you need to work in partnership with the engineering teams on site. But it is also really important to make sure you've got the right segregation of responsibilities and duties. So once you've established a platform, once you've gone in, you've managed to build something out into a site that you want to start layering capabilities onto, what do you put into these platforms? The benefit of having a flexible platform is that you can start to layer in capabilities as you need them in line with your own risk appetite. So it's one of the big benefits we find of implementing such a flexible platform means that you can start to introduce a new capability without having to introduce additional change within an environment. You don't have to go and disturb the field. So as long as you're operating within a set of parameters and rules, which so you're not changing how you interact with the devices, but you may be adding an extra capability based on the data or information that you already have access to. So it can really help in that space. You can start to understand very quickly and in a very agile way which controls may deliver best value to your business and when and where. You can start to look at different technologies. There are no shortage of different solutions out there that may deliver great value in different spaces, but it is incredibly difficult to really evaluate them without it costing you something. There's no such thing as a free pilot. There's even if the product that is on offer for to be evaluated may be being offered without cost, there's still a requirement to bring it to site, to install it, to cable to it, to do that in a safe, reliable way which meets the quality standards of most engineering businesses. Costs internally quite a lot. But if you can just install that as a piece of software on a compute platform, which you've already invested in, you can do that within days or weeks of a proposal, potentially even without having to visit site. So you can start to move away from and work out the difference between what is snake oil and what is something that you can genuinely get value from within your business. And as the final advantage really is, if you're building your own platform and you're able to layer in multiple technologies that you choose when you want them, you're not then tied to a specific vendor, which can potentially deliver a great amount of commercial benefit to you. There are some there are a number of technologies which have evolved significantly from where they first started, because once a customer has established that appliance within the site, they want to try and extract as much capability and functionality as they can, which means a number of the tools out there have really evolved from where they've started into doing many more things, because they are the single organization or single tool set that has got that that foothold within the environment. A great example of that are some of the intrusion detection systems. Many of them have evolved to become vulnerability management tools, to try and identify issues emerging based on on engineering problems in the space. The collection of other information around telemetry and the collection of logs. These aren't necessarily the things that we originally wanted to put in there, but it's the only platform that you have available. What if you could use the best of breed from each of those areas and allow each organization that you're contractually engaging with to do what they are very best at, and do that without constantly having to introduce new appliances or do extra engineering work. And so really a description of where we are in National Grid now. So this is what we've done. We have built just effectively what I've been describing at a high level, and we're starting to roll this out into every one of our industrial facilities. This is not an overnight task. It is probably going to take us 2 to 3 years to roll this type of platform out to the edge of every one of our sites, and it will take us another 2 years probably on top of that to ultimately roll these technologies out in a functional way into those spaces. But we are building a dedicated cabinet to a standard design, which is both physically and digitally secure into the edge of every one of our substations and industrial facilities across the UK and the US. We have landed on a standardized industrial compute platform, which effectively is providing us with our edge compute capability. That it can be connected to the outside world via a variety of different communications links, depending on the type of site that we're installing it on, whether it's on our own dedicated SD-WAN links or on SDH network or satellite links, or sometimes straight onto the edge of the internet in some of our distributed assets in the renewable space. But we're establishing a compute platform within a network security zone, which can host the capabilities that we feel are necessary in each one of these sites. We are running hardened hypervisors and operating systems on these devices, which will allow us to continually build in an environment that we are confident is not introducing any additional risk into those environments. We're building in automation capability to ensure that it's actually manageable at scale. When you're talking around 1,000 plus potential sites that you're deploying these technologies to, and sometimes multiple devices in some of these sites, that's a vast number of assets to maintain. So utilizing the best capabilities we can to automate and orchestrate the maintenance and security of these systems is incredibly important to us. And then we can look at what are we starting to spin up within these spaces. We are one of the key technologies which is tried and tested and proven in these environments is intrusion detection. Having an industrial intrusion detection system is the key detect capability that most organizations are looking to implement, and this is how we are implementing it within our environments. We are running it on our own compute platform. We're not buying appliances. We are implementing our own software-defined networks as aggregation capabilities to feed this platform, so that we have full layer 2 visibility across every one of our sites, feeding into these devices, and in order to detect any potential threat on those, and to discover the introduction of new assets and the existing assets that might be there. We are implementing on this platform our log collection capability to feed it into our SIEM and SOAR platforms. We're using it to host the proxies required to have endpoint detection response tools, antivirus tools in these spaces. We're using it as a secure network zone to provide authentication services to ensure that we know who is doing what within each device in those environments, but also using it to host privileged access management tools that will maintain the local credentials that will have to exist on those assets as well, and to manage those assets that can't you use authentication services and will always have local accounts. We can still manage those using our privileged access management tools. And we have things like the flow controllers required to manage the software-defined networks we're using, to ensure one-way flow of traffic and the safe collection of traffic from multiple networks. And then wrapping around that, we have a really a pattern on how we establish demilitarized zones, always using multiple vendors, always having protocol gaps, and never allowing any network traffic to traverse directly through both firewalls. It's very important to understand the patterns and anti-patterns that exist around the establishment of multiple firewalls, but we do that to ensure segregation of responsibilities, segregation of duty, and to make sure that we're not vulnerable to any single common failure modes or vulnerabilities when establishing this type of connectivity. The air gap is how we've managed and maintained security in these environments for a long time. Introducing connectivity like this is an incredibly powerful capability when, as defenders, when you want to see what's actually happening within those environments. But it's very, very important to maintain a posture which means that we aren't increasing the risk to those sites by adding these capabilities into it. And so finally, really, what's next? What do we do when we've completed those lists, that list of things to install? And the answer is whatever we need. This gives us the platform to work on, in order to connect to new capabilities and new tools. We don't know what the next best tool is going to be. We don't know exactly what challenges our adversaries might throw at us. but by creating a platform which allows security engineers to spin capabilities up quickly without having to physically get back to site is a huge benefit to us, and and we are excited for the future where we'll be able to implement these capabilities as soon as they become available. Thank you.
Hey, Phil. Thank you. Appreciate it. Right now is when we would normally have a large round of applause, and I can almost hear it in my head. Welcome to the new world. But thank you. That was fantastic. I really enjoyed that. I have not collected. Oh, we do have a question come in. I stand corrected. What challenges do you face when you try to implement new security technologies on brownfield sites? Keep in mind, we have about 2 minutes and we might get kicked off because this is slightly.
Yeah, brownfield sites. Implementing this platform at the edge of brownfield sites is very possible. So that tends not to be the issue. Then connecting it onwards into those systems is a challenge. The capabilities of the devices that you're connecting to is the primary challenge. The first being the network itself. So quite often we're having to replace a lot of the network components to get the functionality that we need. Even if we have to leave old relays, PLCs, HMIs, we find it not too difficult to replace the LAN infrastructure on the site. In comparison, it is still a significant expense, in getting those things done. So when we're doing that, we're trying to do that with the lowest regret possible. We are implementing large-scale software-defined networks on brownfield sites. We've got we're probably 180 locations over the next 3 years where we'll be implementing completely new LANs within our substations in order to enable things like intrusion detection systems to be implemented in a highly visible way, and to enable connectivity to the demilitarized zone for things like log collection, should the devices actually do that. Having this platform has also allowed us to start to develop interrogation tools to help us close the gap. So if we can't get logs from a device, we can talk to that device and gather information about it. So it's given us that software platform to start to to do things like device interrogation and close some of the functionality gaps on those brownfield assets.
Okay, thank you, Philip. That is all we have time for at the moment, folks. We're going to head into what would normally be lunch. So if you need to get something to eat, now's the time to do it. Also, if you have one-to-one meetings arranged with our exhibitors, Fortinet, Waterfall Security Solutions, McKinsey & Company, Omicron, who have I left out? Verve Industrial Protection, I'm sorry. Please visit those stands. They have downloads. There's one-to-one meeting opportunities. Phil, it was great listening to you talk about technological selections, because there's a lot of discussion here going on about that as well, and how a company like National Grid or any others can actually demo and procure those in a time constrained environment correctly. So I'd like to talk to you more about that soon. But other than that, we'll be back at 1:55 with a panel session on remote access for OT. We're joined by Perry Peterson at PNNL, Michael Furstenberg at Waterfall Security Solutions. We are also joined by Patrick Miller with Archer International, and Sasha Rigby with Modux. Thank you all for tuning in, and thank you, Philip.